Hello and welcome everyone back home. Welcome to Smart Caps. Well, we're gonna be having lessons for the grade sevens. We're gonna be looking at properties of materials, matter and materials. Our lessons are brought to you by Smart Caps. Caps lessons done the right way, the smart way. Proudly sponsored by VT Africa Holdings and our associates. We're gonna be soon enough, we're gonna be able to log into lessons and be able to stream live with these lessons. But for now, these lessons are brought to you live on YouTube. Let's dive into it. We're gonna be looking at matter and materials. And standing in front of you, of course, Mr. Mofokeng, please feel free to interact, share, like, comment on all of these such that we have a interactive communication and a lesson. Awesome. Remember, what we're going to be looking at today is matter and materials. When we're talking about matter and materials, we are going to specifically be looking at properties of materials. Properties of materials, what we mean by properties of materials, we're talking about traits or things that tell us, that differentiate one material from another. How do we know that this is plastic? How do we know this is metal? How do we know this is wood? Why do we choose metal over wood for doing particular things, for doing particular chores, for getting a glass of water? Why do we choose this over that? When we want to scribble something, why do we scribble over paper than over metal or whatever? So we're gonna be looking at those properties. These are things that you've already done or come across in previous grades. Remember in our grade 4, our grade 5, we looked at ductility, we looked at hardness, we looked at malleability, we looked at all these other properties as to how do they work, what do they mean, and what do they bring to a material. Today, we are going to be focusing on two key properties as we continue building on our knowledge of properties of materials. What we're going to be looking at is two things. We're going to be looking at two particular properties. That is, we're going to be looking at boiling point of materials. We're going to be looking at melting point of materials. These two are very important when you're looking at properties of materials in science. As scientists, we need to know, what do we mean when we say a particular material has reached its boiling point, a particular material has reached its melting point. So we remember when we were doing phase change, phases and all those, we looked at what happens when we have ice. I'm gonna just have blocks of ice and we will see. Here's our blocks of ice. And our blocks of ice, we know over time, if you left it at room temperature, will become liquid. Becoming liquid, you give it a bit of heat, a bit of that, it becomes what? Vapor, of course. Let's have our vapor represented like that. Yes, we have vapor. So these are phase changes. What's happening in between this to this, we remember that as melting. That's our melting process. When ice or solid transforms to liquid, we say it is melting, right? We remember these, we did this. We did these under phase change. When we have our liquid transforming from liquid to vapor, we said this is evaporation. Remember? And that's all great and well. So how does this now interchange or link into this? Awesome. Um, what we mean by, let's start off with melting point. Melting, boiling, melting. I'll start off melting. Let's start off melting point. Melting point of material. Melting point. Come on. Yes. The melting point of material. The melting point of material. That's when our solids are transforming into our liquids, right? They are melting. The melting point of material is the temperature at which where's this? The temperature at which solids transform, come on, to liquids. And at this temperature, this is our melting point. That's when we have this change from solids going to liquids. Yes, we know this. We see this every day. We see this with ice in cool drink. We see this with butter melting in a pan when you're trying to make your bacon, when you're trying to make your eggs. That's awesome. We say it would be melting. It would be our butter would be reaching a certain particular temperature at which it would now be changing its phase or state, right? That's a property of the material. It's independent to that particular material. Each and every material will have its own unique melting point and boiling point. We know that, let's take water for an example. Let me change color and let's see if green looks nice. Let's take water for an example, H2O. Okay. We know that ice will melt to water melts to liquid at, we know that water melts to liquid at 0 degrees, right? When you are going from the negatives into the positives, that's when our water will go from ice to liquid, melts to liquid. Degrees Celsius, right? What does this say? It means that 0 degrees is our melting point for water. And it will vary. It will be different for something else. Other material will not melt at 0 degrees. And hence, this is unique, meaning it is specific or particular to independent materials. So now we know what melting point is. Let's look at boiling point. This color is getting a bit dull. Let's look at, yeah, awesome. Let's look at using that color. This should go away now. Awesome. Let's look at boiling point now. Another significant property to materials that we as grade 7 scientists need to know. We absolutely need to know this, whether you're in grade 7, grade 8, at any grade, even university. As a scientist, you need to know these properties. Boiling point, melting point, these are what make materials. How can we play around with these? How can we play around with these to make our materials better for us, better for the world? So now we're looking at boiling point. What do we mean by boiling point? Let's go back to our water phase change scenario. Remember that drawing of ice, and here we are back here. Ice, liquid, vapor. So in between our water going from liquid to vapor, we have evaporation or boiling, right? So if melting is the temperature at which solids tend to liquids, the boiling point, and I know you have it there, in your head somewhere, you are formulating a nice definition for this, because it should easily become the temperature at which liquid transforms to vapor. And there's so much more happening in between this. As to breaking it down to the minute detail of materials, there's so much happening in this. For your grade 7 level, this is how we will prefer to have it. Temperature at which liquid transforms to vapor, right? And when you are boiling water, when we boil water, here's water, we want to boil it now. We know that water boils at 100 degrees Celsius under standard conditions. What are standard conditions? What do I mean by this? Don't worry too much. Don't bother yourself too much about it, but it means at sea level, material will boil at a particular temperature, and as you increase the altitude, it will boil at a different temperature. Don't worry too much about that. But under standard conditions, which means at sea level, or when atmospheric pressure is 1, but for your standard of level, you need to know that that's when temperature is the temperature at which liquid transforms to vapor. So I need to clarify something very important, so as we do away with misconceptions. What happens when you leave a glass of water outside or on a plate or something? After a few hours, it has evaporated. It's no more there, right? Would it have boiled? No, it wouldn't have boiled out. What happens, which is a very important distinction, is defining between boiling and evaporating. Evaporation. Boiling and evaporation. we need to be able to differentiate between these two such that we do not confuse these. Even in future, we know that there's a difference. We have boiling and we have evaporation. We know that boiling is when liquid transforms to vapor, but so is evaporation. What's the difference then? The difference comes here. I need that beaker of mine. Give me that beaker in blue. I'll have that beaker in blue. I don't want it in black. Here's my beaker of water, and I want to transform it to vapor. So, what happens as I'm boiling? What happens as I'm boiling this water? As I'm heating this water up, applying heat, right? I'm applying heat to this such that it turns to vapor. As I'm applying heat to this, particles inside my water will start to move around more. They'll start to move around more. They'll start to move around more. They'll gain energy, that energy coming from the heat that I'm applying to my water. So as they move around more, they'll have enough energy to now, inside the entire water, inside the water, right? I'm applying heat to this. They'll gain enough energy such that they can escape the bonds that are holding them together and start to form what we call bubbles inside, because they've now escaped those bonds. They form bubbles inside our water and they increase to the top. And we get what? I know you can label this one for me. Of course, we get vapor, right? And that's boiling. We would be applying heat we'll be applying heat. Our particles in water would be gaining energy and escaping the bonds, bonds holding the water together to form what? To form vapor. To form vapor. So what happens with evaporation? What's the difference? With evaporation, here we are now with evaporation. I'm gonna do evaporation in pink. In pink. Pink looks great on evaporation. Oh, green. Evaporation now. So what would be happening with evaporation? There I am, having left my water in this, and there's my water. I had left my water there, and after a few hours, it has evaporated. Right? It's no longer there. What would have happened? Would it have reached the material's boiling point? Of course not. Not 100 degrees that is required. It wouldn't have boiled. But what would have happened is almost a similar process where at the surface, very importantly, at the surface of our water, there will be particles of water, or call them molecules. Molecules. Come on. Molecules. Call them water or molecules, particles or molecules that will gain enough energy at the surface and escape. Meaning by each layer they'll be escaping on their own. They will gain enough energy given the pressure and temperature to escape the surface, and tiny, or as time goes, bit by bit, we will have these evaporating out, forming these gaseous phase of the liquid, meaning it would now be gas up there as it goes there, but not the same way as it would when we are boiling, where boiling takes place right within the entire material itself, where evaporation takes place right at the very surface of the material, making it a much slower process, but still you'd be having the liquid transforming into gas. A very significant difference. So here we are. I'm saying we're applying heat and the temperatures. Isn't heat and temperature the same thing? Oh no, it is not. And I'm going to use those last 5 minutes to make sure I clarify the difference between heat and temperature. Very importantly, we have heat and we have temperature. These are two different concepts. And we, as grade 7s, or we, as scientists, we are going to be sure that we do not confuse the two. And yes, because we are scientists. What is heat? I'll give you a second there. What is heat? Remember, heat is energy. Heat is energy. Heat is energy, right? You either transfer it into materials or take it away by absorption. Absorb it from materials. So it's heat. Heat is energy. So what happens is, as you are applying heat or energy to materials, their temperature will increase. Our material is here, and we're going to apply some fire to it. It will register a particular temperature. And as we increase the heat, to this, the temperature will increase. We'll have T1, and we'll later have a T2, an increased temperature, or we can remove the heat and have a temperature less or lower to this. So if heat is energy, what is temperature? Now what is temperature? If heat is energy, what is the temperature? Temperature. So what is temperature? Temperature is the measure of heat, or the measure of the energy, of the heat energy inside our material. The measure of heat in material. Right? So if I take an initial temperature, here is my evaporizing water, and this is my thermo. How do I draw a bulb thermometer? You'll know how it looks like, right? I'll just, that's my water. That's my thermometer. That's going to measure my temperature. This is used to measure temperature. right? So as I'm applying heat to this, I'm applying energy to this. This is heat applied, meaning I'm increasing the energy that this has, meaning I'm gonna take a T1, first temperature, and have a reading. It will be, let's call it X. And as I'm increasing the temperature or the heat, as I keep applying the heat to this, the temperature will increase, of course, because our material would have gained energy, meaning it would now be recording a higher temperature Y. Don't worry too much about these T1, T2, X, Y. All you need to know is that there's a difference between heat and temperature. There's a difference between boiling point, melting point. There's a difference between heating, boiling and, come on, boiling and evaporization. Cat caught my tongue there. And that is all we have time for today. The screen is now acting up as well. Oh, awesome. And that is all we have time for today. Those two properties, very important. Do go over this again. I would have loved to have. Awesome. Oh, I would have loved to have an assessment for you such that we are clear on these terminologies, as to are clear on what we know and what we don't know. I'll leave a link, maybe there'll be a link under the video such that you have an assessment and you can test yourself and you see. Otherwise, thank you so much. Adios.